Today is January 25th, 2012. We're continuing with our exam review. We're now on part B of the exam review. Question number 4 says to factor. Okay, so we take a look at this. Maybe you guys tried it. These are kind of our factors, and when we multiply them, we actually can't get this. So we don't factor it the way we normally do. If I can't factor this way, what method always works for factoring? Quadratic formula. So the quadratic formula is x is equal to negative b plus or minus the square root. Square root of b squared minus 4ac divided by 2a.
What is that, a quadratic
formula? So, now remember, it's a quick recap here. We're just going to go over what is a, what is b, and what is c in this question so that we can confirm. We have ax squared plus bx plus c. Okay? So the c's in here we have. These are the b's in the equation. There's 2 of them. And there are 2 a's in this equation. So we'll be replacing each of those variables with the numbers above. 2 will be a, negative 4 will be b, and negative 3 will be c. So when we go to plug this in the quadratic formula, we get negative. B is negative 4, so negative 4, plus or minus. Why do they put that plus or minus sign there?
Because you have to have two positive and negative.
Of what?
Equation.
Why do you need a positive and a negative?
Because they balance it out.
What is this sign here?
Square root. Because you can't square root some numbers if they're negative.
You can't square root a negative, but the reason we have a plus and minus is because there's always 2 answers to a square root.
Oh, yeah.
So let's get back to what we're doing. Negative 4 squared minus 4. A is the number 2. C is the number negative 3. And all divided by 2 times 2. Okay, we color coded so you guys can see the letters. Now that we have that, we're going to start to equate. So, again, remember, this is always solving for our x value. Okay? X is equal to negative 4 is 4 plus minus the square root of, what is negative 4 squared? Yeah, 16. Then think of this as a negative. Negative 4 times 2?
It's 84 times 24.
Positive 24. Yeah. Divided by 2 times 2 is 4. We continue. 4 plus minus 40. Square root of 40 divided by 4. Okay? Now, this is where we split it. We'll find what the square root of 40 is. Put it into our calculator here. 6.23. Okay, let's round to at least 2 decimal places when doing this. 4. That's not a 4. Plus or minus 6.23 was it? Or 32? 32? 32. Sorry, I said it wrong. Okay, let's fix this. So, because there's a plus and a minus, we split this equation. 4 plus 6.32 divided by 4 is one option. The other option is 4 subtract 6.32 divided by 4. We deal with the top of the equation first. This would give us 10.32 divided by 4. This one would give us negative 2.32 divided by 4. When we divide them, oops, it's a little much. We divide the 2 numbers, let's see what we get. 10.32 divide 4, 2.58. And the other option is 2.32 negative, oops, 2.32 divided by 4, which is negative 0.58. So the two answers would be 2.58 and negative 0.58 in this question. So those are our two factors, okay? Or our x-intercepts are 2.58 and negative 0.58. Question number 5 says, find x round to 2 decimal places. So, first off, as we just discussed, either we could use sine law, or we could use cosine law, okay? But that's a lot of extra work for no reason. Because this is a right angle triangle, we're going to use something either sine, cosine, or tangent. Okay? So what that means is we need to find reference to what angle we have. We have angle 50. We also have the opposite side, and we're looking for the adjacent side, which means we're going to be using tangent ratio. Tangent 50 is equal to the opposite side is 3. The side we're looking for is our adjacent side, so the x goes on the bottom. Now, a lot of you guys are getting confused here. You can think of it like sine law again, where this is technically over the number 1. Okay? What would we do in sine law at this point? Does anyone remember? We'd cross multiply at this point. So let's say we were to cross multiply here. Yeah, so we'd get x times tan 50 is equal to 3 times 1. Now, 3 times 1, is that going to change 3? No. So we really didn't have to bring that part over. So essentially we'll have x times tan 50 is equal to 3. Now, some of you guys are getting confused. You're thinking that, okay, now if I got to bring tan back to this side, it's going to become tangent inverse. When do we use tangent inverse? When we're solving for what?
Angle.
The angle. Yes, theta or the angle. Tan 50 is actually a number. We just didn't really want to write the entire decimal out. If I wanted to, I can put tan 50 into my calculator. I'll get some decimal number, and then I'll have x times that number. And in fact, what we'll do, we'll split it so you can see it both ways. So, I just equated tan 50. It's equal to 1.191. Now, I need to isolate x in both of these examples. So this is the same stuff, just represented 2 different ways. We need to isolate x. So whatever x is being multiplied by, we need to divide both sides of the equation by that number. And in this case, it's tan 50. 3 divided by tan 50. So what we're going to end up with is x is equal to 3 divided by 1.191. Or x is equal to 3 divided by tan 50. Either way, is the answer approximately 2.5? 2.25? 2.52, yeah, I thought it was 2.5. 2.5, okay? Both ways we end up with the same answer. Okay, question number 6. I don't have it up here, but I'm going to highlight the important part. It says, write an equation of a sine curve. So we're using with a sine curve with an amplitude of 3. So the amplitude is 3. Horizontal translation of 180 degrees to the right. And a vertical translation of 2 units downwards. Okay? They want us to write the equation of this. So I'm going to show you, remember, these parent function f at x is equal to sine x plus. So we have our a, we have our negative h, and we have our k. Okay? Now, let's talk about what each of these variables, a, h, and k, deal with. First of all, a deals with stretching and reflections. It's also exactly what the amplitude is. So if the amplitude is 3, our a is 3. Now, does it say anything about a reflection on the x-axis?
No.
So is it positive or negative?
Positive.
It stays positive.
So if it's a real quick.
Yep. So, H. Okay?
Vertical, horizontal.
That's right. Horizontal translation. Now this one says it goes in a positive direction. So the number we're going to replace this entire negative h with is negative 180. Okay? And finally, k deals with
Going down, so it's minus.
Yep, vertical translations, it's going downwards, so k is negative 2. So when we go to plug it into our equation for this function, f at x is equal to, we'll plug our numbers in, a is 3, h is negative 180, and my fault here, k is negative 2. So this would be the equation of that function. Okay, question 7. We're dealing with exponents. Now, according to BEDMAS, this exponent is outside of everything. So what I'm going to do is I'm going to make this a positive exponent right off the bat. In order to make it positive, what do I do to the fraction inside?
Flip it. Like
Flip it.
everything on the top.
That's right. So we flip this. So now, we're left with a to the power of 5 to the power of 3 divided by a to the power of 3 times a to the power of 5. Because we now made the one on the outside a positive one. You flip the fraction. Okay? Now that positive one on the outside, is that going to change anything? No. So I don't need to write that in anymore. So we have a to the power of 5 to the power of 3.
Oh, you flipped it.
Yep.
Yeah.
Okay? Now we're just going to equate top and the bottom separately. A to the power of 5 to the power of 3. What do I need to do with those exponents? This is a power of a power. Yes.
Where did the 6 come from, sir?
There should be a 6. What is
Also 5.
5? Yeah. This becomes A times B. So we do 5 times 3. And underneath, we have a multiplication rule. What do we do with those two? We add them. So it becomes A3 plus 5. So we have A5 plus 3. So now we end up with a to the power of 15 divided by a to the power of 8. When we're dividing, what do? Subtract. A 15 subtract A. A 7.
Yes, sir.
Okay, we're going to evaluate this. Now, this is a power or an exponent where the exponent is a fraction. So what we need to remember for this is I write our equivalent rule. Say we have x, a over b. It's equal to b as a root and x to that power. Or you can represent it this way, b to that root and then to the power of a. Either of these are acceptable. Okay? And what this is saying is if you have a fraction where a is the numerator, the a comes down and becomes a whole power. And if b is the denominator, okay, b becomes the root of the question. So what we're going to do is we're going to rearrange what we have here. Our base 8 still stays in the same spot as where the x is. So we have 8 to the power of 4 over 3. When we go to rewrite this, 8 becomes our base. We get the third root. The 3 takes the place of the b. And now 8 either goes to the power of 4 or you can go third root of 8 to the power of 4. Whichever you feel will help you evaluate it easiest, both of those are acceptable. Now what we're going to do, the question now says to evaluate. So if I was looking at BEDMAS, say I chose where's option 1 and option 2, okay? Here's 1, here's 2. In option 1, in my head, 8 to the power of 4, I don't really know. It's going to take me a bit to solve. But, oh, you got it? What is it?
4,096.
Good. Now, something I can do in my head, though, is the third root of 8. What number, when I have to multiply it by itself 3 times, is equal to 8? Anyone know? What number times itself 3 times is 8? 2. It's a relatively simple one if you think about it. Oh, let's do it. I'm not sure. It depends what's hard. So, the third root of 8 is the number 2, because 2 to the power of 3 is 8. Okay? Now to the power of 4. Well, 2 to the power of 4 I can solve also. 16. So this is the way I would have liked you guys to evaluate this.
So you got 16, I got 16, but it's wrong.
Was it with your calculator? Is that the way?
Yeah, so I did 4,
Okay, the one on the left,
496.
okay?
4096.
8 to the power of 4 is 4,096. You now find the third root of that, which again you'll have to punch in your calculator. Comes 16. The only reason I did the one on the right is I didn't really need a calculator to solve it.
How do you find that?